Now, earlier on, we have looked into the first property of cross product pertaining to two vectors which are parallel. Now we want to look at another property of cross product pertaining to two vectors A and B which are perpendicular to each other, like in this diagram. So if you have two vectors A and B which are perpendicular to each other, then this angle between them is therefore 1. Theta is 90 degrees, so sine 90 degrees is actually 1. So the cross product of these two vectors, right? The cross product of these two vectors, if they are perpendicular, you just have this. Okay. So now, if we were to take the magnitude of both vector on the left and right side. So what we have will be the magnitude of A cross B equals to magnitude of A can be just taken out, it's just a numeral. Magnitude of B can be taken out, it's also a numeral. And we are left with the magnitude of n cap. And the magnitude of n cap is simply 1 because n cap is a unique vector. And we get this very nice result when two vectors are perpendicular to each other. Incidentally, right? The modulus of the magnitude of A cross B is actually the largest when the two vectors A and B are perpendicular to each other. Okay, now let us look at more examples pertaining to cross product of perpendicular vectors. Say here, if you have the vector I cross with the vector j, right? If you were to imagine this geometrically, draw a diagram like this. This x, this y, and this z. Okay. If you were to imagine this geometrically, the vector I is actually here. The vector I is the vector 1, 0, 0. And the vector j is actually here. The vector j is actually the vector 0, 1, 0. So to perform the cross product of I and j, right? I cross j, according to the definition, right, is the magnitude of I, right? Magnitude of I, which is 1, magnitude of j, which is 1, sine of the angle between them, in this case, if I and j has 90 degrees between them, sine of them is 1 as well, and then times n cap. So n cap is a vector that is perpendicular to both I and j, and it must be a unit vector, and it must also follow the right hand rule. So if you put your finger on I and you curl towards j, your thumb point upwards. So that suggests to you that you want to find a vector in this direction, which is perpendicular to I and j, and also having a unit vector. So a good choice in this case, therefore, would be what? If you want to find a vector that is in this direction and has a magnitude of 1, a good choice would therefore be 0, 0, 1. So now let's do the cross product of I and j. 1, 1, 1, and also 1, and then 0, 0, 1. And you just get the vector 0, 0, 1, which is the vector what? 0, 0, 1 is actually the vector k. Bear in mind, the vector k is actually a unit vector in the direction of the z-axis. So now you realize that I cross j, the unit vector I cross the unit vector j is equals to the unit vector k. And likewise, you can do the same thing, j cross k, you can verify for yourself, is actually I. And then part 3, k cross I is give you j. Okay, you're asked this question as well on the same example. If I cross j is k, what do you think is, on the same part 1, what do you think if I take J cross I, would it still be K? If you were to take J cross I, then based on this definition, right, the magnitude of J is still 1, the magnitude of I is still 1, sine of the angle between them is still sine of 90, which is 1. J cross I. To do J cross I, again, you got to follow right hand rule to get a unit vector direction. This J towards I is pointing downwards. So therefore, in performing J cross I, you'll find that you get 1, 1, 1, and then you want a vector that's downward, you will choose, and you find that this is actually minus K. So I want you to realize that when you change the position, instead of I cross J, if you have J cross I, the answer is the same except that they differ by a negative. And likewise, for if you were to do K cross J, K cross J, you find that you get minus I, and then if you were to do I cross K, you get minus J. Right, so they just differ in direction when you change the order. And that brings us to another property about cross product. This other property about cross product, it is non-commutative. What is the meaning of non-commutative? We are now on page 15, right? We are on page 15. Let me write down for you. We are on page 15 again, page 1-5. Okay. They are non-commutative means if you have A cross B, it is not the same as B cross A. Right? Non-commutative means this is not equal to this, so it's non-commutative, right? Right. In fact, okay, you realize that you have realized from the other discussion that A cross B is actually the negative of B cross A, right? Because of the right hand rule thing that we talked about. Okay, then there is another thing about so-called distributive law. It turns out that for cross product, if you have to do A cross B plus C, to do A cross B plus C, you can technically do A cross B plus A cross C. And you want to realize that when I perform this so-called apply this distributive law, I'm very careful to maintain the order that A comes first. Right, this is something that's different from simple usual arithmetic. No? And then the next one is if you have a scalar multiple like this. So if you have M A cross N B, the good thing is if these are scalars, right? You can pull out the M and N together and just perform A cross B separately.